All right, happy Thursday. How's everyone doing? Have you ever seen a more adorable baby? I mean, I'm a little bit biased, but it's awfully cute in my household these days. So we have a good one today. We're talking about numerical variables. So we're going to go through and try to summarize a couple of numerical variables using two different approaches. So one thing we need to do when we're thinking about our variables is try to summarize them. This is like the big part of what we're doing at the beginning of the semester. And we've spent some time talking about categorical variables last class. So we got our hands on some data and worked on some summarization techniques, both in Excel and in Python. And I showed you the approaches we take to summarizing in Python are nearly identical to those in Excel, except they're generally much simpler. You can make things very complicated in Python, but when it comes down to it, most things can be done very simply. And so we walked through a bit of an example last time. You remember we talked about these different coffee shops. We thought about different choices for summarizing categorical variables. And it turned out your preferences about which visualization was simplest to read, depended a bit on the question and the data type. So we looked at categorical variables. When we did nominal categorical variables like this, where we have an unordered set of categories, and we had more than two unordered categories, we generally thought box plots were the best approach, at least for most use cases. We said, pie charts are fine in some cases. The standard advice is to never use them, but we talked about one example of when using a pie chart can be actually useful. But in general, bar charts are going to be the one that you use with categorical variables. And so we walked through a bit of an example of how we do this. We did not do the binary categorical variable that we talked about in the slides. For the sake of time, we're not going to do this in class. But you can take a look at the slides and try to walk through some of the work we do there. So I've included, we spent a little bit of time on dataset 1 with the coffee shops. There are 3 other datasets that you can work with. And I have the visualizations in the slides for you to continue working with. But we're not going to spend class time walking through these exercises. These are great if you want a little bit of extra practice on your own. So this was the main thing we did in Python, which I've given you the code here to make the summary table and then to make the box plot. Seaborn makes this very easy for us. We just plug in the data set, shops, and then we tell it on the y-axis, we plot the state, and then we can color it by state as well. So we have different colors, and we just organize it this way. And then I've also included some code to make a binary categorical variable. I told you that Seaborn does not have a built-in pie chart, but what we can do is create a binary categorical variable from the categorical variable, the ordinal categorical variable, and then create a count plot, just as we did before. So here's some code to be able to do this on your own. And then the last thing was to create a pie chart, and I've just given you a little bit of code here to make it. I'm not emphasizing this because this is not something we do a lot of, but this could be good extra practice for you if you want to become more familiar with some of these tools. And just as a reminder, in addition to these exercises, there's also homework. So homework 1.1 and 1.2 are available on Gradescope. A couple of common questions about these. You can complete them either in Python or in Excel. So I'm going to show you how to extract figures in an image format from both Python and Excel. So we're going to do both of these things. At this stage in the class, I don't care which tool you're using, and you can use either one for any of these assignments, so feel free to pick the one that you prefer. This is a good chance to get more familiar with Python. It's the tool we're going to use in the second half of the class almost exclusively. So now's a good chance to spend a little bit more time working in Python. But if you just want to answer these first couple of homeworks in Excel just to get started, you're more than welcome to do it that way. Okay, and then there were three other data sets that you can find. I've given you the notebook to work with these. So yeah, feel free to get started, or use these as extra practice. This last one is just we have an order to it, and so you can work with the order. But we're not going to spend a ton of time on that. And then I give you sort of example visualizations in the slides. All right. Aren't these nice figures? I love looking at good figures. I love talking about good figures. Should we do some more of that? Yes, let's go. You're ready to talk about numerical variables? A lot of what we talk about in economics, a big focus of this class, especially in the later portion, will be on numerical variables. We're going to do a bunch with categorical variables, but we're going to spend a lot of time talking about numerical variables. And the place to start, step one, whenever you encounter a new data set, once you've classified the variable types, then you try to summarize the most important variables in your data set. So we've talked about categorical variables. I'm going to show you some nice pictures, and we're going to try to use tools to understand our data sets. So eventually, we're going to end up working with some Starbucks data. So you can download the Starbucks profile data if you like. This is a powerful data set. And I've given you the link for the source here, so you can actually download it from this data website, Kaggle. So you can click on this and take a look at where I got the data set from. But you can see we have customer profiles for lots of Starbucks users. How many of you have gone to Starbucks in the last 48 hours? Some people in the last hour. Yeah, I went to Starbucks this morning. I got a coffee. Nothing fancy, but I'm in their data set somewhere. Not this one specifically, but in one of the data sets. Starbucks collects lots of information about their customers. And as we're going to see in the next couple of weeks, as we work with Starbucks data, they actually can use this data very effectively for lots of different purposes. So it's very useful for a company like Starbucks to know something about who's buying their coffee and some characteristics about promotional offers and income. There's lots that Starbucks knows about us. So this is just a data set. There's gender, age, there's this ID variable, there's became a member on, and then there's some information about income, which I find a little bit creepy. But these are the kinds of things that Starbucks has on offer. So we're going to work with this data set. You can download it directly in its raw form from the link I gave you. But you can also just download the data set that I've given right here. So I've cleaned it up a little bit, but you can access the original source here. Okay, and then we're going to work with this notebook eventually. But for now, let's just think about some nice visualization. So as always, we're going to sort of talk through some things, and then we'll get into the exercise a little bit later. All right. So as always, we're thinking about summarizing the variables that we have on hand appropriately, which is the main set of questions in your homework. So if I were to give you this figure, I've taken the Starbucks customer profile data, and I've created what we call a histogram. This is just, bins. We have everyone's ages, and I'm just putting each individual customer in one of these bins. You've probably seen a figure like this before. If I were to ask you this question, what would be your answer? So which age group has the most Starbucks customers? Yeah. So 55 to 64, yeah. We can tell it's the largest group because the count is the highest. Each one of these bins is just counting up the number of customers in the age bracket on the horizontal axis. But you've noticed something maybe already as I give you the hint on screen. There's something pretty misleading about this figure. And that's the bin sizes are not equal. So remind me of your name? So Luke is saying, look, we have 55 to 64 being the largest. Oh, this is a mistake on the slides. Okay, my punchline is totally taken away. So the bin sizes actually are equal up until 75. So this is a little misleading. I should say it's not misleading. I'm going to have to fix that. So the figure should have been a figure looking a little bit more like this. So my punchline is, wow, this is a great way to start class. Who made these slides? I'm going to blame it on my daughter. Wow, that's a little bit rude. So the figure originally was going to look like this. So we would have equal size looking bins on the horizontal axis, but the actual intervals were going to be different widths. And then I was going to show you this figure to actually show you what the horizontal axis bins would be if we were actually correctly showing the widths. This is a misleading figure, right? Like if we were to show each one of these bins with the same width, some of these bins are much wider. So this interval here would show, a collection of customers from a wider age group. And then this upper age group is much larger. When bin sizes aren't equal like this, it makes it really difficult to answer this kind of question. So Luke actually answered the question correctly and did it very nicely. We have the largest group, according to this figure, with equal size bins is 55 to 64. This is the way we want to set up our figures so that it's easy for your audience to understand. 55 to 64 is the largest group. But if we were to use different size bins, it would be a little bit misleading. Okay, so we've, with this figure, I guess one thing that's maybe a little bit misleading about this figure is 75 is a very large group. And so one thing we can do is spread that out. We know customers in age go up much larger than 75. So we could actually break that out and make a graph that looks a little bit nicer. Okay, so terrible punchline to a great set of slides. But we have other considerations as well. So this picture makes it really easy to see that this age group, around 60, has the largest customer base. But we could also ask more nuanced questions of our data. For example, do 55-year-olds and 60-year-olds have different consumption patterns? Like this question. If we want to distinguish between these two different age groups, this data set, or this visualization, is not very good at answering that question, right? The bin covers both 55 and 60-year-olds. So this bin does not distinguish between those two subgroups. Anyone know what we could do here? If we were interested in distinguishing between these groups, what might we do? Yeah. Yeah, remind me of your name? Jake. So Jake is saying, let's just make the bins smaller. So what a histogram is doing is just counting the number of ages, or the number of observations that fall in the bin, and then just counting them and creating a bar chart for each one of these bins. So one thing we could do, as Jake is recommending, is just make narrower bins. So if you want more precision in your figure, if you want to communicate more detail in the distribution, one thing you can do is create narrower bins. So what I've done here is create bins of 5 years, where before I had bins of 10 years. So this would, allow us to answer the question we had before. You can see the 60-year-olds don't buy quite as much as the 55 to 60-year-olds. So we have these two bins, and you can now distinguish between these subgroups. What if we wanted to take this further? Let's say I want to look at the difference between 44-year-olds and 45-year-olds. How many of you think we could take this down to 1-year intervals? Hands for yes? Hands for no? Okay, the answer is yes, we can do it. I'm going to show you what that figure looks like. What if we want to distinguish between the coffee consumption at Starbucks of 44-year-olds and 45-year-olds? And it looks like this. So this is a figure where we have each individual year, no age groups, just individual ages across the Starbucks customers, going from, I think it's 18 all the way up to 115. And here we can clearly tell 55-year-olds buy more coffee at Starbucks than 44-year-olds. Do you think this is a real pattern? Like, someone tell me, what's going on here? Why does it look like 44 is maybe a third of 45? Yeah, is it ends with a K, doesn't it?
It has a K in it.
Okay.
It's okay, you're good.
Luke?
Is it because we don't have enough observations for it to be a normal curve?
Yeah. First, remind me of your name.
Luke.
Luke.
We got two Luke's and Lucas.
Yeah, that's right.
That's stuff. It's okay.
Yeah, my memory is finite. So we have very narrow bins, which means as we take each individual customer and place them in a bin, we don't get a lot of observations for each one of these bins. And just due to chance, we get a lot of variation between the different bins. So because we don't have a lot of observations in each bin, there's a lot of what we call noise. that's contributing to the sort of spikiness of our histogram. And we didn't see this actually when we had wider bins. When we have wider bins, we have more observations falling into each one of the bins, which kind of smooths out this spikiness. So one thing we can do is reduce the spikiness by placing more observations in each one of the bins. And we can do this generally in two ways. Anyone have an idea for how we do this? I mean, one we've already sort of talked about. So maybe the first one is a little bit simple. There are two ways of doing this. Gonna leave me hanging like this? Oh, yes. So yeah, so we can increase the sample size and increase the number of customers that we're placing into the bins, which just by probability, we're going to increase the number of observations going into each one of the bins, which should smooth out some of the spikiness. You're gonna have to remind me of your name. It starts with an S, I think?
Yeah, Sophia.
Sophia. It was gonna be my first choice, but wasn't confident. Yeah, so Sophia's saying let's do one of two things. The first one is just to increase the sample size. So what we're looking at here, I created this figure by taking 800 customers from the larger sample. So we're only looking at 800 versus the entire data set. But what I'm going to do next is actually increase the sample size to the entire data set. So I've increased the sample size, and here you can see these two ages get much closer to each other. So the random noise that we saw in the earlier figure has gone away. Or it's at least shrunk. Like, we haven't gotten rid of it, but we've made it a lot less spiky, simply by allowing ourselves to place more observations into each one of the bins. And then the other thing we could do is change the bin sizes. And this is something Jake mentioned earlier. We can just increase the bin width. So where before we were going from a bin width of 10 years down to 5 years and then down to 1, here we still have some variation that I'd like to get rid of. So what I'm going to do is increase the bins from 1 year to 2 years. And that's going to reduce the noise beyond what we did by increasing the sample size. Okay, so larger bins collect more observations per bin, and so that reduces some of the noise. We're going to talk a lot about random variation, sample size, and noise when we hit part 3. This is just a preview of some of that statistical thinking. Okay, so we can't answer our original question distinguishing between 44 and 45 anymore because we've put those 2 years in the same bin. But what we can do is distinguish between pretty close intervals. So we can distinguish between the 44 to 45 interval and 46 to 47 interval. So we can do that here. And how many of you think this is a good figure? How do you think it's maybe not a good figure? Okay. Anyone want to represent opinions on this? Why is this a good figure? Why is this not a good figure? Yeah.
I don't know, I just think there's so much going on. Like, you can see who has the most and who has the least, but also there's just so much data in front of you that it's just kind of hard to make out what you're looking for.
Yeah, okay, so and you're talking about all of the different bins. Yeah, so very narrow bins. So maybe it's pretty difficult to, it's a pretty noisy figure in that way. Yeah, for sure. What else? Yeah.
I think a bit of having smaller bins, so you can more easily see skewness.
Yeah, so there are these nuanced properties. One of them is skew for the distribution, the empirical distribution of our data. And one of the nice things about being very fine-grained like this, even though it does introduce a lot of visual components of the figure, it does allow us a much more detailed picture of the distribution. Remind me of your name. Darren. And say that louder.
Joe.
Joe. Yeah, very good, somewhat counterbalancing observations. Yeah, Luke.
I was going to say wider bins because the question is what age group, and I feel like there's not really a difference between a 44 and 48-year-old. So you probably want bins that describe the picture and the question that's being asked.
Yeah. Yeah, nice. So one way this figure may not be great for the specific question we're after is that age group is, we generally consider that kind of larger bins than 2 years. Yeah. What else? Yes.
Yeah.
That's right.
The y-axis or the x-axis or both axes don't have like number labels, so you'd have to base everything along 44, 46.
Yeah. Yep, so I've created a figure that answers a very specific question, which is 44 and 45 versus 46 and 47. But this figure doesn't directly answer, as a couple of people pointed out, doesn't directly answer the question at hand, which is the difference in age groups. And if you were after that question, you should put more horizontal labels. Yeah.
Apart from, I feel like visual criteria, I feel like if you look at it statistically, it seems like a really good data to me.
Yeah.
Because if we look at it from like single year perspectives, it gives us really good information about specific things that we might be looking for. For example,
Yeah.
If we looked at the larger bins, answering a question like how was it different between 44 and 45-year-olds would have been different.
Yeah.
But I feel
Yeah,
like
yeah.
this is more accurate, and also it seems pretty reasonable because this time the 44, 45, 46, all these ages, they seem pretty similar. So it makes sense for it to be this way. So it's pretty accurate to me.
Yeah, this is generally my opinion here too. There are some, like, if I were trying to answer the question at hand, I would add more labels on the horizontal axis. I would maybe take out the red, highlighting the specific year, and then maybe I'd also increase the bin sizes slightly to maybe 5 years. 5 years might be like a nice sweet spot. But if I'm trying to understand the distribution itself, this I think is a pretty good figure. Just maybe more X ticks, and I'd take out the red. So one of the main conclusions here is there is no universal conclusion, right? Like, you have to be thinking about your specific question, the amount of noise that's in your data set, and then sort of tailor your visualization to match the thing you're trying to do. But some general ideas. We want to reduce the amount of noise. I think noise is not a good thing when you're visualizing your data set. This level of granularity, I think, is a pretty good amount of noise. We've gotten rid of a lot of it. And it gives us pretty good resolution. Any concluding comments here? So let's just summarize. Histograms are a great way of visualizing numerical variables. Another typo, who's putting these slides together? Another typo, just say numerical variables. We generally, almost always we want our bin sizes to be of equal size. Remember that really weird looking histogram from earlier? We don't want different sized bins. And then we want the bins to sort of trade off sort of precision and the statistical noise. So we want to try to reduce as much of the statistical noise as we can while giving us a lot of detail about the distribution itself so that we can see things like skewness. Okay, any questions here? You all want to do this? That's not the rousing enthusiasm I'm looking for. So we're going to run through an exercise. We're going to make histograms in Excel, and then we're going to make them in Python. As always, This is a collaborative room, so if you're running into issues, someone else next to you may be as well. So be helpful when you can.